Hello everyone, I welcome to the lecture on the concept of monitors and condition synchronization using the Java programming language. Basically, monitor is a class in the Java which has private variables and whose methods are public and synchronized. So the basic idea of the monitor is that um, it provides mutually exclusive access to data variables in it. So it implements the mutual exclusion. So basically, at a point of time, it provides only one. It provides access to only one thread to the critical section at a time. So to accomplish this mutual exclusion, it makes the variables private, methods as public. So the variables can be accessed only through the methods inside the monitor, and they cannot be directly accessed. And also, um, the methods are synchronized in order to implement the mutual exclusion. If you uh, analyze synchronization, there are two types of synchronization basically. We can use synchronization to implement the mutual exclusion. That means allowing only one thread to access the critical section at a time. And also, the synchronization can be used to implement the conditions, and that is called condition synchronization. Um, for a condition synchronization example, uh, let us discuss a example producer consumer problem. Assume that there is a buffer whose size, let us assume the size of this buffer, let us say 5. 1, 2, 3, 4, 5, 5. And there are two threads, producer and consumer. The producer thread puts the data in the buffer, and the consumer thread removes the data from the buffer. So producer continuously, just assume the producer is continuously putting the data and the consumer is continuously taking the data. So in this case, whenever the producer, initially the buffer is empty, let us have a variable counter to indicate how many data elements exist in this buffer at a time. So initially the counter variable would be 0. So when the producer put the data, the counter will become 1 for the first time, and and sequentially when the producer puts more elements, the counter value increments by one value each time. So whenever the consumer takes any element, removes any element from the buffer, the counter value goes down, decreases by one value. Okay, so producer, when he is putting the element, suppose here the capacity of this buffer is only 5. So when the capacity reaches 5, if the number of elements in this buffer becomes 5, then the producer should not be allowed to put more elements because it would overflow. Okay, when the number of element reaches the maximum size of the buffer, then the producer should not be allowed to put more elements. So we have to make the producer wait until an empty space is created in the buffer by the consumer. Okay, that is classic example for condition synchronization. So we have to implement the condition synchronization in this scenario. What is the condition synchronization? We have to make the producer wait when the buffer is full. Similarly, when the buffer is empty, we have to make the consumer wait. When the buffer is empty, when initially no elements in the buffer, can the consumer take element from the buffer? He cannot. The consumer cannot take any element. When the glass is empty, is it possible for us to drink any water? Okay, when the glass is full, is it possible to pour more water into the glass? So that is a concept here. So when the buffer is full, we have to make the producer wait. When the buffer is empty, we have to make the consumer wait. So this concept is called condition synchronization. So basically, students understand that monitors supports condition synchronization also. It supports mutual exclusion as well as condition synchronization. Okay. Um, so we will discuss this with an example live code. So through that you would understand more clearly about this concept. So now let's create a buffer class buffer. I think there is a buffer class already. Okay. So we'll create another package new. Let's create a new class. So we are creating a new buffer class. So class buffer. It has a array of object. So this array of object is the one which we use to private object buffer new object. Let's say this is size of the buffer. So here the size of the buffer is hard coded. If you want, you can get the input and initialize when you create the object of the buffer object. Then we declare a variable count. So this actually indicates how many values data elements are there in the buffer at a time, and we declare some more variables like in out. So basically in is the index, array. We use index to access any particular element. So in index position is to identify a position inside an array, right? So in is an index variable, out also index variable. In we use to insert any element into the buffer. Out we use as an index when we remove an element from the buffer. Okay. Now let's put a constructor, and we initialize all the values. So the count initially 0, in is initially 0, out is initially 0, and even this we can create an object here, buffer new object, and here if you want dynamically you can get the size, and you can put the size here, and also you can declare a variable size means size indicates what is the capacity of an buffer, how many elements you can store maximum inside a buffer. So this dot size equal size. Now so please understand now what is the behavior of this buffer. It would have yeah array, it would have an array of object in which the threads can store data element and retrieve the data element. They can put and take. So to put the data element you need a method put. To get the element, to take the element, we need another method take. So we make public void put. So this method is used to put the element. So put what? Put any element of type object. Okay. So using this put method, we can put the elements inside the buffer. Okay. So basically, how to put the element now? Buffer of in. We put the element in the position in. In is equal to item. And when just a minute. So this is a buffer. So this is a buffer. It has the size of the buffer is 5. Its index value starts from 1 until up to 4. So initially the buffer is empty like this. So when you store any data element, example d1, okay, you would store that in the position 0. Okay, so after storing that, you would store the second data element d2 in the position 1. So after storing the first data element, you have to increment in is equal to n plus 1. So you have to increment the value like this. Clear to you? uh, okay, so similarly when you want to remove any element, you would remove the element from the position out. So when you remove any element also, for example, you would remove the element out is equal to 0, you would remove the d1, then next out position will be 1. So here after you remove the element, you have to increment out is equal to out plus 1. And whenever you store any data element, the count value also increases. Clear? Whenever you add element. And similarly, when you remove any element, then you have to reduce the count value, count minus minus, or otherwise count is equal to count minus 1. Is it clear to you? Okay. Now we use the same concept here. So we store the element item in the position in. So after storing, what we have to do is equal, we have to increase the value of in. Okay, in plus 1. Okay, and also we have to do a small additional thing, that is the in value first 0, then 1, then 2, then 3, then 4. After 4, okay, suppose this element is removed by the consumer. After 4, the in value should come back to 0 because there is no 5. Okay, it should come back to 0. So to make this in value, after reaching the end of the array, it should come back to the index value to come back to the starting value. You have to do this reminder size. So if you do this, automatically after reaching the end of the array, it will come back to the starting position. Otherwise, array index out of bound exception will be thrown. Then after you put the element in the buffer, after you put the element in the buffer, uh, so basically when the data is inserted into the buffer, the in value also increases, and also the count would increase. So number of element in the buffer would increase. Okay, and so this is what happens when a data element is inserted into the buffer. Similarly, when data is removed from the buffer, to remove the data from the buffer, we use a method called take or get. So it happens like this. We remove object item equal buffer from the position out. So out is the index, and from this index position we remove the element item, and it is of the type object. And once we remove, we have to increment the out value, out plus 1, reminder size. Then also when the element is removed, count value decreases, number of elements in the buffer decreases. So we return the item. So just to recall, we are creating a buffer, and this buffer is created using an array of object, and this buffer has a variable count to indicate how many elements are there in the buffer, and in is the index position to store the element in the buffer, out is the index position from where the element can be removed, size is the capacity of the buffer, total number of elements that can be stored in the buffer. And this is a constructor where we initialize the thing, we create the array of object, and then we initialize the size to the member variable, then we initialize the count to 0, in equal to 0, out is equal to 0 at the beginning. And this buffer class has two methods, one is put and take. Put basically to store the element in the buffer, it is of type, it accepts an argument of argument item of type object, and it stores the item in the buffer in the in position. In is initially 0. After inserting an element, in value increases by 1, and we put reminder size because once it reaches the once it reaches the last index position, the index should come back to the beginning starting value, that is 0. And also we increase the count value. Count increases, count indicates how many elements in the buffer, and the take method basically is used to to remove the element from the buffer. And when you remove the element from the out position. And also when the element is red, what you do is out value index out value is increased by one value, and the count value decreases. So basically, if you analyze this class, uh, this class as of now is not a monitor, because monitor means it should have certain properties. For example, you see this particular part of the code where the count variable increases and here count decreases. Actually, the producer thread calls the put method, and the consumer thread would call the take method. So producer would try to access the count variable, count plus plus. The consumer would do count minus minus. So the thing is that count is accessed by both the producer thread and the consumer thread. They share the variable, as well as they try to update the variable at the same time. Similarly, buffer also accessed by both the producer and consumer. So this entire set of code, we can consider this as a critical section. And definitely, if this critical section is not protected by the mutual exclusion, then the interference problem can arise. Okay. So interference means destructive update, where the count value might go wrong when the producer and consumer they try to do the count plus plus and count minus minus concurrently. The value of the count might go wrong. It's a destructive update, and this problem is called as interference or race condition. So to avoid this, what we can do is we can implement mutual exclusion. Synchronized this. So we implement the synchronization to the critical section. This is the critical section, and to this critical section we have implemented the mutual exclusion using the synchronized keyword. Similarly here, synchronized this. Okay, so now this all the variables are private, so there is encapsulation, and these variables are accessed by the methods inside this class, buffer class. So it satisfies the property of a monitor, and also there is a mutual exclusion. There is a mutual exclusion. We are protecting this variable count from the interference problem by implementing the mutual exclusion using the synchronized keyword. So it also fulfills the property of a monitor. Now what we want is we want to show that a monitor also can support condition synchronization. So what condition synchronization we can implement in this problem is when the buffer is full, For example, now see, there are elements. So when there are elements, now the buffer is full. If the buffer is full, we have to make the producer wait. Okay, so how to implement this condition? While count equal size, it means if the count is equal to size, it means the buffer is full. So if the buffer is full, we want the producer thread to wait. So we call a method called wait. So wait is a method available in Java, which would make a thread. When a thread calls this method, it would go to a waiting state. So thread would be in non-runnable state. So it would enter the non-runnable state, waiting state. It would wait until a certain condition is met. So here actually it is asking for try catch. And similarly, here when we have to make the consumer thread wait. So the consumer has to wait when the buffer is empty. How we know buffer is empty? When count equals 0, the buffer is empty. When the buffer is empty, we want the consumer to wait. Okay, so please, you see here, when the buffer is full, the producer is waiting. How we make the producer wait? By calling a method called wait. Okay, so it would make the producer thread go to a waiting state, and similarly if the buffer is empty, we make the consumer thread wait. This is a classic example of condition synchronization. Understand? Okay, now this actually, please try to understand, when the producer is calling the wait method, it will be in the waiting state. Okay, so for example, you see this scenario. Now the buffer is full, and here, so the producer is calling the wait method, and the producer enters the waiting state. Please understand that each and every Java class has a lock, and the lock becomes active when you make the when you implement the synchronization, when you use a synchronized keyboard. So basically, when a thread calls the wait method, it goes to the waiting state by after releasing the lock. So when the producer is using this put method, actually the consumer cannot use the take method. Understand? Why? Because the producer was having the lock of the buffer class, Now when the producer calls the wait method, what happens? The producer releases the lock so that the consumer can take. Okay, so the producer calls the wait, releases the lock, and goes to the waiting state. Now we want the producer to come back and run. Okay, so please understand, when the consumer remove any element. Okay, now the consumer has removed the element, so there is an empty space here. Okay, so when the consumer remove the element, he can call a method called notify. So when the consumer call the notify method, please understand, the producer who is waiting who is waiting, who is blocked and waiting, he can start the producer continues the running process until this notify is called. The producer would keep waiting. So when the consumer calls the notify method, the producer who is waiting, he would end the waiting state and would start running again and would start the process of putting the element inside the buffer. Similarly, for the consumer, the producer has to call the notify method. So please understand, whenever the wait method is called, we have to use notify. Otherwise, the thread would keep waiting forever. If notify is not given in the program, then the threads would keep waiting forever and it would make the threads enter the deadlock state. So when wait method is used, it should be matched with a corresponding notify method. So this wait method is called by the producer. So the producer is waiting. Now the consumer, after removing the element, would call the notify. So when this consumer calls the notify, it would put an end to the producer waiting. Similarly, when the producer puts some element in the buffer, he would call the notify. So when the producer calls the notify, it would put end to the consumer waiting. So this is a classical example of condition synchronization. So you see this buffer class, you can see all the variables are private, methods are public, and there is mutual exclusion, and also there is condition synchronization. See, this is condition synchronization. So this is a monitor. This buffer class is a monitor. So this monitor class basically prevents race condition. Also, it prevents data overflow, and also it prevents the deadlock. Okay. So now, so we have to create two threads. One is producer and consumer, and we will make the producer and the consumer call this buffer class and methods in the buffer class, and we will see how the output comes actually. So this already I have done. You can see this. I have done this already. So let me run and show you this. So this is the buffer class. This is the consumer thread, and this is the producer thread. So the consumer is calling the take method or get method, any name you can do, and consecutively it removes the element, and the producer calls the put method. It puts some number, integer object into the buffer. Okay, let's see the output. You can analyze this output. See, the producer is putting the data, count 1, count is 2, count 3, count 4, count 5, and now the consumer is removing the element. Okay, so now please you can understand that when the buffer is full, the producer would wait, and when the consumer when the buffer is empty, the consumer would be waiting. Okay, so this is a example to show the concept of monitor. So let me recall the things what we have discussed before. Monitor in Java, if you want to implement, it's a class, very simple class. in which variables are private, methods are public, and also there is a mutual exclusion for the critical section. It supports a mutual exclusion for the critical section. You can see this example. Okay, there is a mutual exclusion, and also it supports condition synchronization. So you know what is condition synchronization. Clear to you? So this is the concept of monitor, and also I have explained that using the producer consumer problem. So in the slide you can see the producer consumer problem, put method and the take method have been explained, which we have done practically. So please understand here, yield method is used instead of weight. Weight is better than yield method. If yield is used, please understand it would lead uh, into a deadlock state. It would result the problem in a deadlock state. It would cause deadlock. So it's not a good method. So a strong suggestion is that in problem like this you should avoid the yield method. Instead you can go for weight method. And also yield method, if called, what happens, a thread would go from running to runnable state without releasing the lock, whereas the wait method no would make a thread go from running to waiting state after releasing the lock. So wait is safe method, it doesn't result in a deadlock state. Whereas the yield method would result a problem in a deadlock state. So we have to avoid this. Okay, so you can see this, if yield method is used, please understand producer would wait, the producer would be waiting, as well as it would make the producer and the consumer wait indefinitely without making any progress. It would result in deadlock state. Okay, so preventing deadlock, how to prevent the deadlock? The best way is remove the yield and put the wait and notify. And also please understand, when we use the wait method, we have to use the notify. Suppose we forget the notify, then again deadlock can happen. Deadlock means just the threads, they would be waiting for some event to happen, and that event will never happen. So the thread would keep waiting forever, and that state is called deadlock state. So we can use the wait and notify. So please understand, when notify method is called, please what happens, it would make a thread which is waiting in the wait set to come out of the wait set, and it would enter the runnable, and from the runnable it would start running. There are two methods actually, similar methods. One is notify and another one is called notify all. Notify would suppose in a wait set, if there are many threads waiting, many threads are waiting, just assume. Okay, so if the notify method is called, it would send only one thread out of the wait set. Okay, it would bring out only one thread from the wait set. If notify all method is called, okay, it would bring out all the threads which are in the wait set. So all the threads now they can come out of the waiting state, and then they can start running. Is it clear to you? So that's a difference. Please understand, when a wait method is called, a thread goes from running state to waiting state. And also please understand, it would be, these threads would be temporarily stored in a data structure called wait set. Okay, and when Another thread calls a notify or notify all. Please understand, the thread which is waiting in the wait set, it would come out and it would enter the entry set, and from the entry set it would go to the runnable state, and from the runnable state it would start running, it would reach the running state. So difference between notify and notify all is very simple. Notify would bring out only one thread from the wait set to the entry set. Notify all would bring out all the threads in the waiting set to the entry set. So that's a major difference. So this is what I want to tell about the producer and consumer problem. Thank you very much.